All right, so picking up with the hypertonic, hypotonic, and isotonic, and picking up with salinities and what happens to cells. We look here, here's a red blood cell. Here's your red blood cells right here. And if you place these red blood cells into an environment of distilled water, and distilled water has nothing in it, that's a hypotonic environment. That will cause the water to rush into the red blood cell, causing it to swell and eventually burst. And that is referred to as hemolysis. Hemo, H-E-M-O, lysis, L-Y-S-I-S. So you throw it together real fast, hemolysis. Over here, you place it in an environment of a lot of salt, a salty environment. That pulls water out. So the water leaves, and then the surrounding pressure pushes in on this plasma membrane, and it causes it to look spiky like that. So that's causing the cell to shrivel. And when an animal cell shrivels, that's known as crenate, C-R-E-N-A-T-E. It crenates. So here, this is an actual photograph on the slide, and here is your red blood cells in the isotonic environment. You got like little donuts. The salinity or tonicity is being increased, and that's causing the cells to crenate. Here, the salinity is being decreased or being put into a hypotonic environment, and the cells are starting to swell up, and they eventually rupture. So that's hemolysis. Exocytosis and endocytosis, when you play the PowerPoint, and you can do that, you'll see that the things moving out when large molecules move out, exocytosis and such. Here's an example of it, of both endo and exo. So look at the prefix endo, so in the cell. So here's the food, it's being taken in, and if it's large molecules, that's known as cell eating, phagocytosis. It's brought in, a lysosome or digestive enzymes merges. It then digests those particles, bringing them down to the molecular level. They then diffuse out, and then the waste, what's left over, is passed out or removed, left, exit, exocytosis, removal right there. And this is another animation that you can play, and you can see that this is a type of a contratransport. When we get to the urinary system in AMP2, you might want to look back at this. Receptor proteins, these proteins have a specific shape. They have a certain molecule that meets them, like a lock and a key. We mentioned that before. They then they attach, and this will change shape on one side or the other, and then that can facilitate other reactions within the cell. So there's that contratransport again. Carrier proteins, they'll pick up a molecule, it causes them to change their shape, and then they release the molecule across the membrane, and then they change their shape and go back, kind of resetting and going back and forth and back. And this, when you play this one, here's a vesicle. A vesicle is just a small container. They're small and large. Vacuoles are large, vesicles are small. But they're made up of membrane. And these will go and fuse, and then material gets shot out. Exocytosis. It depends on the size. I told you just previous about phagocytosis, cell eating. If liquids are brought in, then that's known as cell drinking, and that's known as penocytosis. And then here you can see a large amoeba-like, when you play this one, you see this large amoeba going and engulfing this food particle, similar to how a white blood cell in your body's immune system would go and take in a bacteria or some other foreign invader. So there you go. Woo, we got through that one.